Find all the real or complex roots of this degree 6 polynomial. Luckily we have choices, otherwise we would have to do long division 6 times. It's not really favorable from my side. I don't know about you. If you enjoy long division, you can of course proceed with that 6 times. But here, if we get this question in the exam, we'll try to be a bit clever and minimize the number of times we need to do long division. So the first thing I want you to notice is that -1 is a root in all of them. So it's not really giving us any useful information. I'm just pointing this out. The same thing goes for 3. It's not really giving us any useful information there. And then we notice that we have 2 choices, which include 1. So we ask ourselves, why wouldn't we, give it a shot? Plug in 1 and try to be a bit clever and see if 1 is actually a root. If 1 is a root, then we kick out 2 choices. If 1 is not a root, then we still kick out 2 choices because it's either 2 1s or 2 2s. So what I'm gonna do now is I'm going to write p of 1. So 1 to the 6 is 1. And then the other stuff are just, so x to the 4th is 1. If you multiply something by 1, it just goes away. This is, I think it is obvious. And if we add these numbers up, actually, what we get is the following. So 24 plus 18, that's 42. And then you add 1, that's 43. Yeah. And then when you take away 18 and then take away 8, that's taking away 26, then 30, then 31. So clearly this is not equal to 0. So 1 is not a root. So I'll leave out the computation and I'll just keep this fact. This is what we've just revealed for these 2 choices. So these 2 choices cannot be the answer because the 1 is not a root. I hope that's clear. Okay, then we have these other roots. So it's either this set or that set. If you want to divide by a complex number, sure, go for it. Like, I don't mind at all. But I wouldn't, I don't mind that you do it, but I would mind that I do it personally because it's more complicated. So if you have this, you would really ideally look to divide by a real number. We will talk about the method of checking whether the number is a root or not. We've already discussed it, but I'm just trying to see if there's a test we can do to figure this matter out. So here, for these 2 choices, 2 is also a root, so it's not really that useful. Same thing for 1 plus i, same thing for 1 minus i. So the only thing that can really differentiate between the 2 is either, so it's either -2 or -3 is a root. So one of the following is true. Not both of them are true. So it's either -2 is a root. From here we can conclude that either p of -2 is equal to 0 or p of -3 is equal to 0. And how do you check this? Okay, so for 1, it was easy because you just remove them. If you want to start computing minus 2 to the power of 6, sure, you can do it. If you really don't like polynomial long division, but here we enjoy it a little bit, so I think we will test it. So choose one of the roots. I will personally choose minus 3. So is minus 3 a root? How do we check this? And this should not be too difficult to check, because by the fundamental by the fundamental theorem of arithmetic, we know we can write our polynomial as a product of its x minus its roots. So in this format, we know also that it has 6 roots because it's a degree 6 polynomial. And so the trick here is if minus 3 is a root, then dividing p of x by x minus negative 3, which is plus 3, but I'll leave it as it is, yields no remainder. That is our test. And it makes sense because it's going to be one of those. If it is a root, then this is true. If minus 3 is a root, then we have no remainder. If it gives us a remainder, then it is not a root, and in that case, the answer would be C. But let's see for ourselves. So, I've actually set up the venue for us here already. I will do the computation. You can skip, of course, if you feel like it's not useful for you. So, how do we do long division? Well, x and x to the 6th. We know that x to the 5th, when multiplied by x, gives us x to the 6th. So we write x to the 5th. And then we take away x to the 5th times x plus x to the 5th times 3. So we take away the product of x minus 3 and whatever we write down here. So we will get x to the 6th. That's how we chose x to the 5th. And then you add 3x to the 5th. Now I've mentioned this once, I'm not going to mention it every single time. And now I will proceed with the computation. Minus 4x to the 5th, minus 3, so that's minus 7. Now repeat, you get minus 7 x to the 4th, that's obvious. And then it's minus 7 x to the 5th again. And then minus 21 x to the 4th. This always cancels out. And then we have this and that. So it's 21 x to the 4th minus x to the 4th. So it's 20 x to the 4th. And we continue. So we have 20 x to the 4th. So if we divide this by x, we get 20x to the 3rd, and then 20x to the 4th, plus 60x to the 3rd. Then they cancel out. Minus 60 and then plus 18, so that's going to be minus 42 x cubed. And then we go on. So divide this by x, you get minus 42x squared. Take away the product, so minus 42x. And then add, well, you don't add in this case. In this case, you'll take away 126x squared. Now, what is the remainder then? Well, positive 126, because there are two minuses, and then minus 18. So it should be 108x squared. So divide this by x, you get 108x. Now we don't actually care about this result that much. We just want to see if we will get a remainder or not. That's really the main goal. So keep this in mind. This is the goal of this process. And then 324x. So these cancel out. Here we have negative 324, and here we have negative 8, so that's going to be negative negative 332x. Then you divide this by x, you get 332. Minus 332. And then we do this process one more time to get, and then take away 332 times 3, which is, I think, 996. And clearly this is 996, it's positive. And this is 24, so it's 1020. But that is the remainder. So the remainder is equal to 1020, and it is not equal to 0. So I can write that the remainder is not equal to 0. And then, if that is the case, then minus 3 is not a root. Simply. That's how simple it is. I mean, it's not that simple, but we try to make the problem as simple as possible. Then, if p of minus 3 is not the solution, then the solution must be c. You could have also chosen minus 2. So you divide by x minus 2, so you divide by x plus 2. Now, an exercise for you, check that p of x divided by x plus 2 has a remainder 0. I could just say it has no remainder. And a nice exclamation mark. This is a good exercise for you to try out. So the answer indeed will be, as you can see, it will be C.